Okay, in this video, I'm going to be introducing a series on work done. And in physics, we know that work is a measurable quantity, just like we do work in our everyday life, like sweeping, like mopping the floor, like walking, like lifting objects. So in all these cases, work is done. But in physics, how is work done? How do we calculate? How do we measure the quantity of work done? So you can see here from my note that work is done when the force moves its point of application through a certain distance. So to do work, the force must be applied, and that force must move the object in a distance. That distance must be moved in the direction of the force, and it's also defined as the product of force and distance moved in the direction of the force. So distance moved in a certain direction, in a specific direction, of course, you know that that is displacement. So we can see that work done is a product of force and displacement. Of course, distance moved in the direction of the force is displacement. So in symbols, this W, that's my work done. F is the force applied, and S is the displacement. It means that we can derive the unit of force, unit of work done as follows. That's force is Newton and distance moved is a meter. So a work done of 1 Newton meter is the same thing as the joule because the SI unit of work done is the joule. And of course, in base units, as in terms of kilogram, in terms of meters and seconds, work done is expressed as kilogram meter squared per second squared. Now, I have a question here I want us to calculate. The question says, calculate the work done by force of 5 Newton, which moves an object through a distance of 10 meters. Now, the work done here in solution is force times distance or displacement, that is distance moved in the direction of the force. And to express work done in joule, what you need to note here is that the distance moved must be expressed in meters. In some cases, in exam question, they may express the distance in centimeters or even in millimeters. You need to know how to do some conversion, converting distances in other units to meters. So here now, luckily, the distance is in meters. So there's no point doing conversion here. So my work done is calculated as 5 times 10. That gives me a work done of 50 joule or 50 meters per Newton, 50 Newton meters. Sorry to say. Now look at the question 2. You have this object of mass. Sometimes they may give you the mass of the object, let's say 2 kilogram, and this object is lying on this level floor, this horizontal surface. I can see the way the force is applied. It's applied at an angle 30 degrees to the horizontal. So if eventually this object moved a distance of 10 meters, the question is this: calculate the work done by the 50 Newton force. What is the work done? Now, if I go on to just use 50 multiplied by 10, that will not be correct. That will be incorrect because the applied force is not the same direction as the direction of distance moved. The distance moved is along the horizontal, along this line. This is the direction of the displacement, and the force is not exactly the same direction as the direction of displacement because the box eventually moved from this point A. Let me label this position A to this position B. So what I have to do here is to resolve the 50 Newton force, which acts at angle 30 degrees with the horizontal. I'm going to have two perpendicular components of the 50 Newton force. And one of them is acting along the direction of the distance moved by the object. Of course, we call that the x component. And we have a component of the 50 Newton force that is acting vertically downwards like this. That is the y component. Okay, so in doing that, I can even translate this to a right angle triangle by drawing this. So this makes a right angle triangle. This is my 90 degrees. Then I use my SOHCAHTOA. Of course, this is my adjacent side, which is my x component of the force, 50 Newton. This is my opposite side, which is the y component of my 50 Newton force. So I can use sine, for instance. If I use sine x, or sine 30 rather, it gives me y over 50. So the vertical component or the y component, which is acting downwards like this, is 50 sine 30, which gives me 25 Newton. Of course, this 25 Newton is not the one responsible for the distance moved by the object, because the object actually moved this distance, which is horizontal. But the 50 Newton force, the 25 Newton force rather, acts in this direction vertically. So let's find the x component using the cosine. Cos 30 gives me, that is adjacent here over hypotenuse, that's x over 50. So my x component is equal to 50 cos 30. So when I find that, it will give me the value of the force that is actually acting in this direction. So that the work done in this case, generally speaking, is calculated by using F cos. If F is the force applied, let's assume that F is the force applied. F cos theta, where theta is the angle that the force line makes to the horizontal. Okay, that's F cos theta multiplied by the distance moved. Let me call the distance moved S. So that will give me Fs multiplied by cos theta. So this is a general expression for the work done when the applied force makes an angle theta degrees with the horizontal. If the force, or if the angle was to the vertical, that would be Fx sine theta. Because let's say you are given this angle theta, for instance, and I want to find the components along the direction of the displacement. If this angle was rather given and not this angle here, so I'm going to use opposite over hypotenuse. So it gives me f sine theta multiplied by distance d. Okay. So I have my parameters. I have the f as 50. I have my distance as 10 meters, and I have my cos 30. That's cos 30 as 0.8660. So multiplying this together, I have 500 multiplied by 0.866. That gives me the answer 433 joule. That's the work done by the force. All right, so you can see that work is done when a force moves an object or moves its point of application through a certain distance, and that work done is expressed in joule. Okay, so in the next video, I'm going to explain various types of work done. Okay, see you in the next video.